Alrighty, welcome back to another build of the quarter scale speeder bike. If you remember from last video, this is where we left off with this piece, and I've been working on making the plug for the carbon fiber body fairing. Let me show you what that looks like. So if you remember in the last video, I had this just all covered very sloppily in Bondo. And this is it all sanded back. It's not done yet. I need more here. Anywhere where the Bondo is not sanded, I need to put more. And if you remember right, I didn't like the curve here. It had a weird bump in it here. So I need more Bondo here. Same thing here. And just a little few places where I need to put some more. A couple places here and here. But I think probably one more coating of the Bondo here, and then sand it all back, and I should be ready for some primer, and that'll show me where any pinholes are that I can then put some spot glazing putty in it, and then hopefully primer and paint, and then ready for the carbon fiber. So that's what that's looking like. And while things on this are drying, I thought I would go ahead and work on the next part, which is these. And of course, those are the pontoons that stick out and hold the front wings. And when you measure these, when you measure those, they are that end, you're looking at about, I'm going to round that to 5.5 millimeters. This end, you're looking at about 3 millimeters, a little over 3 millimeters. And the length, we're looking at 5 inches in length. And yes, I'm combining metric and standard. And feel free to let me know in the comments how you feel about that. But ask me if I care. So again, making everything 3 times bigger. That means these are going to be 15 inches long. They're going to be 15 inches long, and then about 16.5 millimeters diameter on that side and 9 millimeters on that side. So obviously I'm going to need a taper. And for the material, I actually didn't have anything here in the shop. I thought I had some aluminum bar, but apparently I don't. So I had to go buy some. I went to my favorite steel shop, and I bought a 6-foot length of 3/4 inch aluminum. And so these right now are cut to about 18 inches, but they only need to be 15. And where that line is here, from here to here would be 15. Can't quite get it all in the camera. But I need room to hold the material. And I need to machine a feature on this end that will attach it to the inside of the body. And so the taper will start down here. And I'll need to machine some features on here to hold the different bell cranks and the front wing and some other things. So I'll start turning these down. I'll try to record that. I've never done a long taper like this. I've done short tapers. But for this, I'm going to have to do between centers. I'm going to have to unset the tailstock and do it between centers. So I've never done anything like that before. But so that should be interesting. I did buy a 6-foot length of this, so I have just enough to retry 2 more times in case I screw both of these up. And if I screw up 4 pieces, then I got to spend another 20 bucks on another piece of aluminum rod. Now, one other thing I want to mention. There's also these pieces here. And these go on like this. They go on like this. There you go. And I don't know how well you can really, yeah, it comes up okay. But it looks like there's a bell crank here, and then a rod here and a rod here. And that kind of bell crank geometry just doesn't quite work. And I've tried looking at other images online of how other people have made their artist rendition of this. And they're all very similar to this. Some of them have kind of an L-shaped bell crank, which would be fine. But to have a bell crank perfectly in line with the rods, that doesn't quite work. And I also can't tell if this piece here, you know, in some other images I look at, this piece looks like a bell crank to where they depict it to where it looks like it pivots here. So this would move in and out. But in other images, this right here looks like a linear actuator, or maybe some kind of a gas strut or a shock absorber or something like that. So maybe that's stationary and that's a gas strut. So maybe this is a dampening for the front wings. But regardless, this obviously in somehow or in some form moves back and forth this way, whether it pivots here or if that just extends and retracts like a shock absorber or an actuator. This is trying to move in and out this way, but it's straight in line at that bell crank, which should just kind of push on that. And I don't know if this piece is supposed to pivot back here. Some images I've seen, this piece looks solid, like it just holds that piece. But in other images, this piece had a hinge point right here. So there's like a link here that could flip back and forth, plus that could flip back and forth. But then you get into a really unstable mechanism that could just go over center and lock itself up. Either way, it doesn't work. And then the other end of that goes to a rod that curves around to another bell crank here. Well, on some images I've seen, that almost looks like it should push and slide back and forth this way. So it almost seems like there should be a slot in that tube and then a rod that goes through the tube and then pops out here to control the wings. Either that or this is supposed to rotate about that bell crank, but this geometry, that can't happen. So I cannot find a single image of the geometry or figures of this bell crank setup that would actually function or do anything. It's almost as if they just threw together a bunch of random mechanical junk to make something look like it's supposed to do something for a movie prop. Yeah, trying to... So, you know, basically, I can do whatever I want to this. I want it to work. I want it to function. On my model, I want these pieces to move, but I want them to move in a meaningful way. And the way this is set up, that can't do that. So I get to do what I want, which is good and bad. It's good because I get to do what I want, and it's not right or wrong. It's bad because I get to do what I want, and half of you watchers are going to tell me that it's wrong. But I'm still trying to decide what I want to do here. I'm not too sure yet, but I will definitely let you know once I figure out what I'm doing. But first thing I want to do is get those long pieces kind of turned down to shape. Now what I will probably do is at this end, I will bore a hole halfway through so that if I want a rod to go through that and pop out here to move the front wings, then I'll have that hole there to do that. But yeah, let's... First, let me get another coat of Bondo on this thing, and then while that's curing and stuff, then I'll put those rods in the lathe and see if we can start turning those tapers down. Okay, so what you're seeing right now versus what you just saw, over a week has passed because I had to go away for business for a week, or business, for my work. I had to go away for a week for my work. And I don't really remember exactly where I left off, but I'm pretty sure we were talking about these pieces here. And I'm pretty sure I showed you the aluminum rods that I had cut. So I cut two pieces, and from here to here for scale is about 15 inches. And so I made these about 18 just to give myself extra room to hang on to. And in the lathe, I parted off and put a center point on each end. And on this end, I went ahead and I bored a hole that goes all the way down about 7 inches to about like here. And I used this drill bit, and I actually wanted a hole a little bit smaller in diameter than this. And but I didn't have one long enough. Yeah, about there. I didn't have one long enough that was a little bit skinnier than this. I have, you know, I have this one, but it's not long enough. And same with this one, it's not quite long enough. I have this one, which is long enough, but this one is bent. And right there, it's actually bent right out where I needed it to be. So what I would do, just to help out this bigger bit, is I would drill through as far as I could with this one, open it up with this one, and then run that one, the bent one, through as far as I felt comfortable, and then finish it off with this one. And the reason why I wanted a hole bored through there is because I'm pretty sure I pointed this out earlier, but these bell cranks sit on here like this. And one of those bell cranks just goes in like to that rod, like right there. So something is happening inside of here at that point. Now, some images I looked at, this almost looked like a sliding piece, like there'd be a slot, so this moves in fore and aft. Others I looked at, it looked more like a bell crank. Of course, it'd have to be positioned the other way. So I'm not sure exactly yet what I'm going to do in here, but either way, whether I'm turning a shaft inside of here or sliding a shaft back and forth, I need to have access to that. I need that to be hollowed out so I could put in whatever I want to put in here. Again, I still need to figure that part of it out, but I went ahead and put the hole through here so I have access from here all the way up to here to do something. And it would be easier to bore that hole before I turn the taper. And again, it's a little bigger than I wanted, but that's fine. It's still smaller than the outside diameter of the end of the taper. You can see here that outside diameter right there. That is how big the final end of that taper will be. I was shooting for 9 millimeters, and that's close enough to me right there. So again, as I've stated before, nothing I'm doing here is dimensionally accurate. Close enough is good enough, as long as they're both the same, is all I'm really shooting for. And that hole will be plugged when it's all done. I'll just turn down an aluminum plug and shove it in with some Loctite and smooth it all up, and you'll never even see the hole when it's all done. So anyways, I did 2 of them just like this, turned to the exact same length, and then I turned the taper, and here's what that looks like with the taper in place. And again, so the end, I was actually shooting, like I said, I was shooting for about 9 millimeters, and that's, again, perfectly close enough. It's a little bit more than that piece that I turned down at the very end. You know, the further you get to the end, the smaller it's going to be because it's a taper. But, so again, close enough. The other end of the taper, I was shooting for, if I remember right, I was shooting for about 18. And I got, if I can get that in view here, I got 16 and a half. But that's actually, I think my batteries are going dead. You can barely see that. That's 16 and a half. But that's actually close enough, because when you measure that part here, depending on if you measure this way or this way, you can get several different measurements. You can get anywhere from 5 to 6. So again, if it was 5, then I only need 15 for here. If it was 6, I needed 18, and I've got 16.68 there, or 16 point, well, we'll call it 16 and a half. So this is perfectly well within the scale dimensions of this piece. But more importantly, it's 15 inches from here to here. And what I'll need to do is put a hole here, cut the excess off, but again, I left it long to give me something to hang on to. Now, as far as turning this taper, let me show you how I have the lathe set up. And I set up the taper by offsetting the tailstock. But let me show you how I figured that out first. I had an idea of how it needed to be, or I had an idea of what I needed to do, but I just drew this out as like a sanity check. So one end I was shooting for 18, so I put a center line, and I did 9 and 9. The other end I was shooting for 9, so through the center line, 4.5 and 4.5. So I was assuming I just needed to move the tailstock towards me 4.5 millimeters. And just to draw it out again, I drew a center line and then shifted the tailstock that 4.5 millimeters. And then, so this is the shape I was looking for. This is how it's laid out in the lathe with the center line. I don't know how well that's showing up in the video. I think it's all right. But as you can see, what I ended up with, just laying on the drawing there, is pretty much perfect. Exactly what I was looking for. So let me show you how I have the lathe set up. So basically, I've got my back plate, and I have the center point. And with the tailstock, I adjusted these screws here. There's one on the other side as well. And you can actually see how offset it is here. And basically all I did, I used a dial indicator to measure from that point to that point, and that's as close as I could get it to 4.5 millimeters. And then I just shoved this back. I just shoved that back, and then I just put the part in between the centers. Let me get that set up. I'll show you what that looks like then. Okay, so hopefully we'll be able to see all of this. I've got the drive dog in here. I taped a piece of paper towel in there just because it was rattling a lot. It's driving from this edge, obviously it's going this direction. And so I just put a piece of paper towel in there just to take up the slack, just so it's not rattling. And got that end here, and got the end here. And this is the cutter I'm using. This is just one I've had for years. It does an okay job. I honestly, I need to invest in some better cutters. I need to invest in a quick tool change, but this is, this is the old school thing I've been using for a while. It works. And I got the power feed set up, and hopefully that light's not going to glare too much. I don't know how well we're going to see this. But just to kind of show how I'm doing it, we'll turn it on here. I'm just going to turn that in just until it touches here. And I'll crank it back a bit. Now keep in mind, I am not a professional machinist. And then I'm just going to crank in here just a little bit, and we'll engage the power feed here. And it's only going to go a little bit before it stops cutting, because again, it is on a taper. And this is a very long, drawn-out process. I've learned that if I take too deep of a cut, then it really, well, the part slows down, and I think that's because the belt slips. I need a new belt. I kind of really need to rework the belt setup and the tension of the belt. But as long as I take lighter cuts, it works fine. Every once in a while it does kind of squeal and chatter, as you heard in the beginning of that. But it's not really cutting that much anymore, so I'll just disengage the power feed here. I'm going to crank it back and just turn in about that much. Engage the power feed, and you see it slowing down and bogging down a bit. I might have been a little too aggressive there. And again, it could probably be, I probably need a different cutter. Maybe just need to sharpen that cutter. I don't know. But this is a very long, drawn-out process, because I basically need to get that end from, what is it, 19 millimeters down to 9, by taking just a little bit at a time. I think I'm doing like maybe 0.5 millimeter at a time. But and as you can see, it's starting to take lighter and lighter cuts. So every time I do that, it gets a little further down and a little further down. So I just keep going until that end is 9 millimeters, and I'm about 15 inches. And then that'll put that end right at about the, what was it? I already forgot, 15 and a half or whatever it was. So that's pretty much it. I'm just going to have to stand here for the next several hours and back this off. And as you can see, it's it's not cutting here, it's cutting here. So the rod is, obviously the rod's not perfectly true, but by the time I get that down and get that down over here, it will look exactly like this one. And once it's all down to dimension, then I just go at it with, I think I use a 120 grit sandpaper, then a 400 grit, and then some steel wool. I just go over some steel wool, and that gives a nice surface finish on it. So let me get the other one done, and then we'll figure out how we can mount this in the milling machine and put our attachment hole here. Okay, so I've got this piece clamped in the mill, and ideally I'd put something here like an end stop to make sure the new one or the other one goes in at the exact same distance from that edge. However, I did make both of the blanks exactly the same length, so it's going to have to be good enough to do it on this end. So basically, I've got it clamped in there on a V-block, and I basically just took a straight edge across the vise and the end of the piece just to make sure where my distance is. So when I put the other one in, I will leave the I already got the y-axis locked at that point. So when the new one goes in and I set it up the exact same way, then I will be at the exact same place here when I drill the hole. So basically what I did to start, I used the edge finder, my electric edge finder. I found that edge, and I did the 1/2 function, moved it back to half. And so now, before I drill the hole though, I'm going to mill and I have the DRO set to half. I'm just going to mill a flat, just to make it easier to then drill that hole. Plus that flat will give something for that to clamp solid to when I bolt it in place, or if I need to fixture it somewhere, I'll have a nice flat reference to do that on. So the first thing I'm going to do then, and I'll do it off camera just to save noise and time, but I just have an end mill. I'm just going to deck that off flat. Again, dimension wise, not critical. I'll probably just make it flush with the top of where that taper starts, just so I have a nice flat surface right there. So I'll get that milled off, and then I'll set the DRO to the 0 point where I already set it, and then I'll drill that hole. All right, so there's the flat milled in. It's a little smaller than I imagined, but it'll be fine. It'll still work. And I got the center drill in there now. I got my X and Y zeroed from where I wanted to center drill it. So we'll go ahead and just pop the center in. So now I'll swap that over for the drill bit, and give me a second, we'll get back with the drill bit. Okay, I didn't make you watch me drill the hole, but there's the hole, and I chose that size very specifically so that if I wanted to use my hold down set, I could just put the threaded rod through the hole and clamp it somehow on the table, and that'll become a fixed reference point for the other features. It got a little close to my milled flat than I would have liked, so I'm going to go ahead and mill that down just a little bit more, which is fine. I still have maybe a millimeter before I get into this, which is fine because up to about here is under the cover. You're not going to see any of this once it's all together. So I'm just going to deck that off a little bit flatter, a little bit lower here, and then I'll show you what that looks like all done. All right, and I think I'm going to end it there. Went back that way a little bit more, and it just started touching the taper. I don't know how well you can see it with the lighting, but it just started touching the taper. So I'm going to end it there. I think that's a pretty good hole size. So again, for clamping purposes, I can it'll go with a little persuasion. I don't want to get it too big. I don't want to get it too big because then it'll be loose on that. But I think that's pretty good. I'll just kind of have to gently open it up a little bit. But anyways, I want to use these to clamp it down for future operations and for mounting it in the model. There'll be an aluminum plate that will set on with a bolt going through. So I'll have a flat, nice flat there. It'll get cut off probably right there, probably right where that flat ends. I'll cut it off, and I'll probably put a flat on the bottom side as well. More than likely it's going to be clamped between two aluminum plates when it's installed in the model. I think I'm going to end this video here now. I kind of feel bad because I keep saying that I'm going to get the carbon fiber on the body. I think I've said that the last 3 videos that I'll get the that I'll get the carbon fiber on the body, and I haven't done it yet. I will at some point, but I'm going to stop promising when. I would like to by next video, but who knows? But the next step is to get the other rod in this setup and drill that hole, and then I can start thinking about how to fixture it to get the features in here for the other bell cranks and for the bracket for the front wing. And as long as both rods are completely identical, then it'll look good when it's done. So like I said, I'm going to end this one here. And as always, until next time, thanks for watching.